Okay, hello everyone. Today we are going to speak about mobility. So I'm Anthony Chavan from HF Group. I'm Global Marketing Manager for Pvd application and I'm in charge of the hydrogen project for the group. HF is involved in many topics in mobility for hydrogen, and today I will make a focus on the most important one for us today is coating for bipolar plates. So some quick words about HEF because it's not a well-known player in hydrogen environment, but we are a big company. We have 70 years experience in surface engineering. We are in 21 countries with 86 plants. We are more than 3,000 all over the world working to improve surface performance. And our specificity is 66 of the shares belong to the employee, and you have also our turnover. So we are in many fields of activities. The major one are construction, defense, medical, green energy, so production of hydrogen for sure, and mobility. Mobility, we come from mobility and we want to develop solutions to improve future mobility and clean mobility. We have three main activity, core business in blue, which are tribology, science of friction. We have photonic, which is science of light, and we have electric applications linked to hydrogen production or hydrogen utilization. And we have different core business, different model of research and development, equipment and consumables, jobbing service, what we are going to do for bipolar plates, and complete manufacturing supply. In the group, we have several technology we have developed internally. So we have thermochemical process, vacuum process, where I'm linked, the bushing, and we have two main technology which are emerging, which are laser texturization and powder functionalization. The aim is to combine different technology to create a material which not exists right now and which will improve and improve the performance of a surface. So why we are here? Today we are going to speak about fuel cell. So everybody have huge wishes for fuel cell, but there is problem linked to the price of the technology because it's an expensive technology. One of the most expensive components is this little one. It's a bipolar plate, okay? And the bipolar plate right now they are using graphite, and it's a good solution, but it's heavy and it's quite expensive to perform and to process. So at HEF, we want to perform an economical, recyclable, robust coating solution for metallic bipolar plate. So we want to change from graphite bipolar plate to metallic bipolar plate, and I will explain how we will succeed that. So why we believe at HEF that we can do that? Because for the automotive market, there is a lot of challenging questions. And so if you are not aware of this challenge, it's difficult. So first thing, we come from the automotive world, so we know the challenge. Secondly, to do a perfect coating for this type of application, you need to do Pvd coating, physical vapor deposition coating, and we are expert in this one. We also have developed a fuel cell dedicated lab. We have an industrial prototyping platform. We know how to perform inline equipment to perform bipolar plate at the lower price as possible. And also, very important one, nobody is speaking about that, but when you want to make 10,000 millions of bipolar plate per year, you cannot control it at 100% by eye. You need robots. You need automatic control, and this is something we manage. So today, I'm not going to speak about a research and development solution. I'm going to speak about an industrial solution that we are going to put everywhere in the world. So some bipolar plate basic, because I don't know if you are all fuel cell specialists. So the bipolar plate, in fact, it has three missions, okay? The blue one is a simple one. It has to be impermeable to the gaze. Easy one. So you can use what you want. The green one and the orange one are more technical. In fact, you need two things. You need a very low resistivity of the surface of your bipolar plate, and you need an excellent chemical inertia. So in the world, right now, you have two main technologies which are industrialized. You have the graphite one, and you have the coated metal. So metal, it means titanium, or it means stainless steel. What is the main advantage of coated metal? You can come on our boss to see that. This one is 2 millimeter thick, okay, and heavy. This one is 0.1 millimeter. So if you have to put 400 plates in your bipolar, in your fuel cell, this one with coated metal will be more compact. And everybody is looking for compact solution. You just have to check in your pocket and look to your phone. Nobody wants a big phone. Everybody wants a small one. It's the same thing for the fuel cell. So for bipolar plate, what we can say? In fact, we believe at HCF it's linked to professional mobility, okay, for tomorrow. And you have two types of professional mobility. You have the heavy professional mobility, which are train, big boat, and for this one, graphite solutions are really suitable, perfect. But when you want to have light professional mobility, and a lot of people is looking to that today, the best solution is to have a metallic one. But for the metallic one, you need a coating, and this is what we propose. Up. Just a quick presentation about the way you produce your bipolar plate. You have two possible solutions. First one is what we call pre-coating solution. So you do the coating, and after you do the bipolar plate. Good solution on the paper. Second solution is the post-coating solution. So you do the bipolar plate, and after you do the coating. Right now, fuel cell for light mobility application, it's an emerging solution. Okay? You do not have 10,000 fuel cell cars in the street in Paris. No, it's no way. So we need to guarantee to the OEM, to the tier one, that the coating will survive in the most hardest condition. So for us, the post solution is a good way to start the business, to securize that this technical solution is a good one. So, as I said, post-coating for metallic bipolar plate, it answers the most robust solution. After, there is always a question of price. Price for PVD application, for coatings, it's linked to equipment improvement and multiplication. This is the way you decrease the price. So you make more plants, more machine, and so you have a decrease of the price. So for sure, we can guarantee the best performance-price ratio, and it's also more easy to duplicate the process flow. Imagine you have one big machine in the world that can coat in pre-coating. If you want to duplicate this plant, it's really, really complicated. So with post-coating, we are more agile to follow our customer all over the world. I remind that HCF is an international company. We have customers all over the world, in China, in Japan, in US, in Brazil. So tomorrow, we will have to duplicate our plants everywhere in the world. And finally, one important point, the fuel cell market will be so large in the future that you will have several solutions depending on what you want to achieve and what type of fuel cell you want to achieve. I finish about Pvd coating and PVD coating for metallic bipolar plate. So our winning strategy, it's quite simple. We already did that 15 years ago for mobility application for internal combustion engine, and we succeed. So we duplicate exactly the same strategy because we know it's a winning one. So we have created an chemistry laboratory to study the reactivity of our coating with the environment of the fuel cell. We have developed a specific coating, and we are going to develop, and we are developing right now, high productivity equipment to match the price requests of the market. Just some word about the PVD coating development. I don't think you are familiar with PVD coating. So PVD coating is physical vapor deposition. It's an under vacuum coating. And we are doing this coating in 4 steps. So first we clean the part. After we put it in the equipment, we pump all the air in the equipment. We do a plasma etching to clean the surface. After we make the coating, which is a carbon-based coating. And after we cool the part and it's finished, you can send it to the OEM or the tier 1 to assemble the fuel cell. So we are working for low temperature fuel cell and also high temperature fuel cell, which are used in aviation and where the weight is a real problem. We are coating several materials. The main ones are titanium and stainless steel, and we can do several coating. The most efficient one is gold. Gold is too expensive, so we have developed a carbon coating, which is really, really suitable for this application. Just some data about the coating. So to control the quality of the coating, we have several tests to perform, and in fact, it's a multi-scale methodology. And we do ex situ corrosion test, so it's a lab level. We have in situ monocell characterization, so with famous laboratory like the CEA or the one. And we have also in situ fuel stack validation with the OEM and the fuel cell producer. So for the third one, you can imagine that I'm not going to show some result because it's secret. So we will be focused only on point 1 and 2. So I don't want to be too technical. So this is basic information, and if you want more data, you can come to the booth to discuss about it. The objective was to have a coating, a carbon coating equivalent to gold. So you have two things you need to securize. First thing is the interfacial contact resistant. It's the conductivity of the coating. And so you can see the red curve is equal to the yellow curve. So it means the carbon has the same conductivity than gold. So first point is good. The second point, what is really, really important, is the corrosion of your layer. Gold is the best solution. Why? Because it cannot react in the environment of the fuel cell. Okay, it's thermodynamically stable. So the aim was to find the good carbon composition which has the lowest reactivity in the environment, and this is what we did. And in fact, the reactivity of the carbon we have developed is so low that you have the impression it's gold. So you have a really, really, really long durability, higher than 10,000 hours in the latest test we have performed. And last thing, which is really, really important, is the coating degradation. So we have made several tests with several laboratories. This one is a high power stress test done with the CEA for 1,000 hours. And in fact, you have two curves, which seems to be the cell. First one is after 1 hour, it's the orange one, and blue one is after 1,000 hours. So in fact, with our coating, after 1,000 hours of stress test, equivalent to 10,000 in real life, you have no coating, neither plates, neither membrane degradation. So this solution, the research and development is finished. Now it's time to industrialize it. So I'm not speaking today about a new material, but I'm speaking today about a new product which is available on the market and which will be launched in France. So we are developing right now the new generation equipment that will allow us to produce an equivalent of 10,000 fuel cells per year. Okay? And our next big step is in 2025, we will have our new plant with our new equipment, with our new process, totally finished, and it's a 25 million euro investment in France, so here in Andrézieux-Bouthéon, where the headquarters of the HUF group is. And we will be able to produce an equivalent of 50,000 PMFC per year. And the next step will be for 2030 to duplicate this plant all over the world. Gracias. Merci beaucoup. I hope my English was not too bad. And see you on booth H38 to discuss about the possibility to use the latest and best solution on the market. maybe you have question, and if you don't have, it's okay. Because it's already 5:20, and I think I'm good on the timing. 3 minutes to go. So who wants to ask a question? Nobody. So it means it was absolutely perfect and absolutely awesome. So I have to drink a beer now with my colleague, and I wish you an excellent day and an excellent exhibition.